Welcome to 10.4. This is your last and final lesson of the year. Congrats, you made it, and you're actually still alive, okay, believe it or not. So in this lesson, 10.4, we're going to talk about fourth and final way we can solve quadratic equations. We've already talked about factoring, we talked about using square roots. The last lesson we did completing the square, and the fourth and final way we're going to talk about is what's called the quadratic formula. Okay, it's this big, ugly looking thing right here. It looks awful, but it's actually not that bad. It's just a lot of math and squaring, adding, subtracting, multiplying, dividing, things we're really used to already doing. Okay, it just looks bad. But some of you might actually remember this. I think you may have done this last year in Algebra 1 towards the end of the year. Okay, so the quadratic formula, it's really just a plug and chug formula where we're just going to plug in some letters or numbers for A, B, and C, and it's going to give us an answer for X. All right, so one important thing about the quadratic formula is since we're using A, B's, and C's, our equation has to be in standard form. Okay, we talked about 3 different ways our equation can look, and the first way was standard form. We also talked about vertex form and intercept form, but in order to use the quadratic formula, it has to be in standard form, and that means that it has to equal 0. Okay, so your goal is to move everything, numbers, variables, absolutely everything, to one side of the equation. That way you can have 0 on the other side. Okay, so it has to equal 0, and it has to be in standard form. All right, so let's take a look at our first example. We're going to solve and graph this equation using the quadratic formula. So first let's solve it. We want to figure out what is x equal to, and we said that it has to be in standard form, meaning it has to equal 0. So right now our equation equals 5. If we want to equal it to 0, let's subtract the 5 from both sides. That way those are gone. So we would have 2x squared plus x minus the 5, and it finally equals 0. All right, so that's what we want to get. Now, in order to use the quadratic formula, we need to know what is our a value, what is our b value, and what is our c value, because we're going to plug those numbers into our little formula. So a in this case would be 2, b would be our little kind of invisible 1, and c we have a negative 5. All right, so you might need to reference the quadratic formula. Hopefully you wrote it down on your note guide kind of towards the top of the page, but we're going to plug these numbers in the appropriate positions. All right, so how you kind of read the quadratic formula is the opposite of b. Okay, I know there's a little negative sign there, but the way it's said, the way it's pronounced is we say it's the opposite of b. Then we have plus or minus, and we have a bunch of stuff inside of a square root. We have b squared minus 4ac, in other words, 4 times a times c, and absolutely everything, okay, from the opposite of b all the way to the end of the radical, absolutely everything is divided by 2a. Okay, so there's our quadratic formula. Let's plug in our little a, b, and c values into the appropriate places. So we need the opposite of b, in other words, we need the opposite of 1, which would be negative 1, plus or minus. Then we need b squared. Okay, so if b is 1, 1 squared, 1 times 1 would give us 1. And we're subtracting 4 times a, which we said was 2, times c, which we labeled as negative 5. All right, and again, absolutely everything is over 2 times a, or in other words, 2 times 2, which would give us 4. All right, so now it's just a little bit of simplification. We can figure out what the inside of this radical is. All right, so we have negative 4 times 2, which is negative 8, and then times 5 would be positive 40. So we have a positive 40 all over 4. And finally, we have negative 1 plus or minus the square root of 1 plus 40, which would be 41, all over 4. All right, now some of you, in some cases, we might be able to break apart the radical depending on what the number is, but the square root of 41, there's not a perfect square that goes into that, so this is just going to stay the way it is. Now, some of you might want to leave your answer like this, which is completely okay. Okay, if you want to leave it like this because it's technically as simplified as you can get it, that's absolutely all right. But in this particular case, since the directions told us to graph it as well, this solution right here is our x-intercepts. Okay, since we solve for x, we know where we might be able to plot this answer on our x-axis. But the problem is, this answer we got right here, we don't really know where that is on our axis. I don't know where -1 plus the square root of 41 divided by 4 is on my graph. So this is when a calculator is going to be a useful tool. Okay, so let's try to figure this out. We need -1, and maybe I'll add 41 first. Okay, square root of 41. Okay, so when I do the top, the -1 plus square root of 41, I get about 5.4. But then I need to divide that answer. Okay, notice how I'm dividing the whole thing. I got to divide this whole answer by 4. And we get about 1.4. Okay, so maybe we'll say x equals 1.4. Okay, that's one of our answers. But then we need to do -1 this time minus the square root of 41. Which would give us -7.4, and then again dividing it by 4, our last step, we get -1.9. So x equals -1.9. Alright, so now that these are decimals, okay, we just took our answer and made them into decimals, we can plot these decimals. We have about 1.4, which is about right there, and then -1.9, which is almost -2, but not quite. Alright, so there's our x-intercepts. Now we got to find the vertex, okay? But since some of you might like to do the little counting thing where you make your little swooshes or humps, but in this case it's going to be really tricky because we have decimals. We don't really know the exact middle, so maybe this is where, since our equation is in standard form, we can go back to the 10.1 lesson where we talked about another little formula we have, x equals the opposite of b over 2a. And notice how this formula we talked about in 10.1 to help us find the vertex is directly related to the quadratic formula. I have the -b over 2a. Okay, so the only difference with the quadratic formula is you have this extra square root quantity right here, and towards the end of this lesson we're actually going to talk about what this tells us, but the vertex equation that we had in 10.1 directly comes from this quadratic formula. So since we already know what b and a is, let's find our vertex. We need the opposite of b, which in this case again would be -1 over 2 times a, or 2 times 2 would give us 4. Alright, so we know the x value of our vertex is -1/4. So maybe we'll draw our little axis of symmetry at -1/4, somewhere right there. But I got to figure out the y value because I don't really know, is the vertex up top, is it in the bottom? So if this is an x value, let's plug it into our equation and get the y value. So we'll have 2 times -1/4 squared plus -1/4 minus 5. Right, so if we do that, let's check it out. We have 2 times, now I'm going to use a decimal, -0.25 instead of a fraction, but you can use a fraction if you want to, squared plus -0.25, and we subtract 5. Alright, so our y value of our vertex, what was it again? We had -5.125. 125. Alright, so there's our vertex. Now we can label our vertex since we know an x value that was -1/4, and we found our y value to be -5.125. Let's plot that. So we already have our axis of symmetry. We got to go down a little bit more than -5. 1, 2, 3, 4, 5. Somewhere right there. Alright, so let's connect our graph. And make sure yours actually go through your dots, okay? It should look something like that, okay, but there's our graph. So another way we can solve equations, or these quadratic equations, is using the quadratic formula. And again, just like all the other graphs we did this year, or so far in this quadratic section, they always look like a U or a parabola. Alright, let's check out our next one. Same directions. We want to solve and graph this quadratic equation by using the quadratic formula, and we want it equal to 0, so we need to move, in this case it's equal to 5x minus 9. Okay, we got to move the 5x minus 9 to the other side. Alright, so I'm going to try to do this without writing down steps. I hope I don't confuse you guys. But if I subtract 5x from here, that means I got to subtract it over here. So this is -1, and I'm subtracting 5 more, so that would give me -6x. Then to move the 9 over, I need to add the 9, so those go away. And if I add the 9 over here, that's just going to be a number on the end. Okay, so you can, if you want to actually write out the steps in your little column here, that's okay, but to make sure I have enough room, I'm going to kind of do it up here. So I did 2 steps in one, just move over the 5x and that -9. All right, so let's label our A, which is 1, B is -6, and C we have is 9. So our quadratic formula, maybe we'll write it up here. We have the opposite of B plus or minus the square root of b squared minus 4ac. All of it, absolutely everything, is over 2a. All right, so let's plug in our a, b, and c values. We need the opposite of b, so we need the opposite of -6, which would be +6, plus or minus the square root, b squared. Okay, so we need -6 squared. -6 times -6 would give us a +36. Then we need to subtract 4 times a, which is 1, times c, which is 9. And absolutely everything, again, is over 2 times a, or in other words, 2 times 1, which was just 2. All right, so let's clean it up a little bit. We can do a little bit inside the square root. We can do -4 times 1, which is just -4, times 9 is -36, again, all over 2. But then if we take a look at it, the square root, we have 36 minus 36, which is just 0, all over 2. And the square root of 0 is just 0. So it's like this part disappears. Okay, we no longer have a square root, and all we have left is 6 over 2, which is just 3. All right, so there is our x-intercept in this case. If we go back to the last one, okay, we labeled this as our x-intercepts. We actually had 2 of them. Okay, in this case, we actually only have 1 x-intercept. So let's graph that. We can graph the number 3. Now in this case, since we only have 1 x-intercept, okay, this x-intercept is actually acting as our vertex, okay, because if you think about it, when these 2 x-intercepts over here, we were able to find the vertex in the middle of them. But if this is our x-intercept just like the last one, the middle of this point is the point itself. So this point is actually our vertex. We only have one answer, and that one answer is our vertex. So really all we need to do is try to find another point to help us graph our parabola. All right, so you can pick any other point you want. Okay, feel free to pick negative numbers, positive numbers. The only thing you can't pick is 3 because you already know where it is on a graph. So maybe I'll just pick 2. Okay, but again, you can pick whatever you want. So if I let x equal 2, I'm going to take that number 2 and plug it into my equation. I have 2 squared minus 6 times 2 plus 9. All right, so that's 4 minus 12 plus 9. 4 minus 12 gives me a -8 plus 9, which gives me a 1. All right, so my other point has an ordered pair 2, 1, which means I can plot that 2, 1 right there. And using the symmetry idea, okay, that axis of symmetry, the mirror point would be on the other side, somewhere right there. So let's graph our parabola. All right, so these are very similar to the ones that we did in 10.1. Again, we're just solving them a different way. Okay, we're using the quadratic formula. All right, let's do one last graph. Okay, again, solve and graph using the quadratic formula. We want it equal to 0, so instead of it equaling 2, let's move the 2 over and we'll subtract it. So we have -x squared plus 2x, and then that minus 2 we move over. All right, now it's equal to 0. All right, so label A, we have -1, B is 2, and C we have as -2. All right, quadratic equation, we need x equals our x-intercepts. We have the opposite of B, which would be -2, plus or minus the square root of b squared. Okay, 2 times 2 would give us 4. Minus 4 times a, that's negative 1, times c is negative 2. And absolutely everything is over 2 times a, so 2 times negative 1 would give us negative 2. Alright, so let's clean it up a little bit. We have, on the inside, negative 4 times negative 1 is positive 4, times negative 2 would give us negative 8. And that's all over negative 2. Keep cleaning it up a little bit. On the inside of the radical, we have 4 minus 8, which is negative 4, all over negative 2. Bum, bum, bum. Do we notice something? All right, if we keep cleaning it up a little bit, we have the square root of negative 4. Okay, we cannot take the square root of a negative number. What does that mean? We need the imaginary I. Okay, so that's coming back into play here. The square root of 4 is 2, but again, since it's negative and we can't have a square root of a negative number, we need the imaginary I. Okay, so we can simplify a negative square root. We've already talked about that. We're going to do it again in this lesson. And everything is still divided by negative 2. So, thinking about imaginary numbers, how we broke them or divided them separately, we can have 2 divided by negative 2, which would just give us a 1. And we have plus or minus 2 divided by 2 would give us a 1i. Alright, so there's our solution for this case. But let's talk about what this actually means on the graph. Okay, if we go back to the second one, we got a real answer. Okay, this number 3 is a real number, so we can actually plot it on a real coordinate plane. If we go back to the first one, we got real numbers, 1.4, negative 1.9. We can actually graph those on a real plane. If we look at the third one, okay, this is not the imaginary plane. Okay, notice how I did not write real and I did not write imaginary. This is still the x-axis and this is still the y-axis. Okay, this imaginary number cannot be plotted on a real coordinate. It can only be plotted on the imaginary coordinate. Alright, so if we cannot plot this, and this is our answer, this is supposed to be our x-intercept, we actually don't have an x-intercept because we can't plot it on a real axis. So let's write no x-intercept. Alright, if we go back over here, we had one x-intercept. We only really got one answer. If we go back to the first one, we had 2 x-intercepts because we had 2 answers. But notice on this last one, we don't get a real answer. It's an imaginary answer, so there's no way I can plot an imaginary number on the real coordinate plane. So I can't put any dots on this x-axis, which means that our graph never touches or goes through the x-axis. So let's try to plot this anyway. Okay, if we think about our little formula for the vertex, we need the opposite of b over 2a. If we take the opposite of b, again, that would be negative 2 over 2 times a. Okay, 2 times negative 1 would be negative 2. Negative 2 divided by negative 2 is a positive 1. So the x-coordinate on my vertex is 1. So maybe down here, kind of small, we'll say our vertex coordinate is 1. So I know our vertex is somewhere on this line. We don't know if it's up top, in the middle, down below, so we got to find the y-coordinate. So let's take this value of 1 and plug it into our equation. We need the negative, then we have 1 squared, plus 2 times 1 minus 2. 1 squared is 1, but we have the negative out front, so that makes it negative 1. 2 times 1 is 2, minus 2, and we're just left with negative 1. Alright, so the y value of our vertex would be negative 1. So 1, negative 1, there's our vertex, somewhere right there. Okay, let's try to find another point. Again, you can pick any point you want. You can pick a negative number, a positive number. You just can't pick one because that x value is already used. Now, some of you might actually remember from 10.1 how we can find or use another specific point. This c value is your y-intercept. So if you don't feel like picking another point, okay, 1 is kind of already given to you. This negative 2 is your y-intercept, so we can plot that right there. And then symmetry would put the other point on the other side. Okay, so we can draw our parabola going that way. All right, so I think that's all we're going to do for this part of the lesson. I think this is going to turn into another two-parter. All right, so just for now, focus on solving and using the quadratic formula. We're going to get into this no x-intercept, 1x-intercept, 2x-intercept idea based on what our answer looks like. That will be in the part 2. Okay, so just focus right now on the quadratic formula and using this long process to try to find your x-intercepts. All right, so I'll see you later. We're going to work on this a little bit more next class, and get ready for part 2. Almost done.